Hello everyone. In this video, I will explain derivations for the equations of kinematics for all the methods. So, first method is common method. In this method, we will try first equation which is known as velocity time relation given by v is equals to u plus at, where v final velocity, u initial velocity, a acceleration and t will be the time. So, to derive this equation of motion, let at t is equals to 0, velocity u and at t is equals to t, means after time t, velocity will be v. As we know that the rate of change of velocity known as acceleration, so we can write a is equals to v minus u divided by t. Now by the cross multiplication in next step we can write v minus u is equals to at. Now as we rearrange this equation, then we will write v is equals to u plus at, which is first equation of motion, also known as velocity time relation. So this is the derivation of first equation. Now second equation of kinematics, which is known as position time relation and given by s is equals to ut plus half at square. To derive this relation, average velocity VAV is given by x minus x naught divided by t, where x will be the position of the object at time t and x naught will be the initial position at time t is equals to 0. Let this is equation 2. Now average velocity can be also calculated by the relation VAB is equals to u plus v divided by 2. Let this is equation 3. As both equations 2 and 3 will represent average velocity, so we can write from 2 and 3 x minus x naught divided by t is equals to u plus v divided by 2. Now we can substitute the value of v from first equation of kinematics. So we get x minus x naught divided by t equal to u plus, in place of v we will substitute u plus at. So it will be u plus at divided by 2. Now as we simplify, in next step we get x minus x naught is equals to ut plus half at square. In place of x minus x naught, we can write s, which is displacement. So the equation will be s is equals to ut plus half at square, which is the second equation of motion. Like this is equation 4. Now the derivation of third equation of motion, which is known as velocity position relation and given by v square is equals to u square plus 2as. So initial steps are very similar as we used in second equation. Average velocity is equals to x minus x naught divided by t. Let this is equation 5, and it is also given by VA is equals to u plus v divided by 2. Let this is equation 6. Now from 5 and 6 we can write x minus x naught divided by t is equals to u plus v divided by 2. The next step we will write x minus x naught is equals to v plus u divided by 2 multiplied by t. Let this is equation 7. Now we will substitute the value of t from first equation of motion. As the first equation of motion is v is equals to u plus at. As we simplify, we get t is equals to v minus u divided by a. So we substitute this value in equation 7. We get x minus x naught is equals to v plus u divided by 2 multiplied by v minus u divided by a. Now in place of x minus x naught, we will write s. Here we use the identity a plus b into a minus v, which is written as a square minus v square. So there will be v square minus u square divided by 2a. And next step, it can be written as 2as is equals to v square minus u square on v square is equals to u square plus 2as, which is third equation of motion. In fourth equation of kinematics, we will derive an expression for displacement in nth second, which is given by s nth is equals to u plus a by 2 in bracket 2n minus 1. So to derive this expression, displacement in nth second s nth is equals to displacement in n second minus displacement in n minus 1 second. This is equation 9. Now the value of Sn means displacement in n second from the second equation of motion, it can be un plus half an square. This is equation 10. And displacement in n minus 1 second. So from second equation of motion, it is u in bracket n minus 1 plus half a in bracket n minus 1 whole square. This is equation 11. Now substitute these values from equation 10 and 11 in equation 9. So we get s nth is equals to un plus half an square minus u n minus 1 plus 1 by 2 a in bracket n minus 1 whole square. Now simplify it. So in next step, un plus 1 by 2 an square minus un minus u plus 1 by 2 a using a minus b whole square n square plus 1 minus 2n will be there. The next step, un plus 1 by 2 an square minus un minus u plus 1 by 2 an square plus 1 by 2a minus an. Now further simplify un plus 1 by 2 an square, open the bracket, so minus un will be there, plus u minus 1 by 2 an square minus 1 by 2a and plus an. Now simplify, so un will cancel out. Similarly, half an square and half an square will also cancel. So next step, s nth is equals to u plus an minus 1 by 2 a. Further simplify, so u plus, consider a by 2 as a common, so there will be 2n minus 1. So this is the final expression, which is represent displacement in nth second. Let this is equation 11.